In this video, we're going to introduce the concept of solving for x. Another mathematical term for solving for x is solving one variable equations. An equation is just two things on either side of an equal sign. Let me give you a very basic equation. 8 minus 3 equals 5. There's an equal sign, and there are things on either side of the equal sign. Those two sides equal each other. Now, one variable equations are when there is it's usually a letter, usually it's the letter x, and that x stands for a mystery number. We don't know what x equals at this point, but we can use some rules and tricks to figure out what x equals. So let's take a look at how to use algebra tiles to solve something like 8x minus 3 equals 5. Let's take a look at this example from CPM. So we have our algebra tiles here, and we learned in the inequalities video where instead of an equal sign, there was a big question mark to see if this side was greater or this side was greater, or in some cases, if the sides were equal. We are now going to figure out the value of x. Because it says that the sides are equal to each other, we are able to figure out what x equals, specifically what it equals. So let's use the same moves or tricks or rules that we learned in the last inequalities video to try to simplify both sides. I don't have any opposites with the x's, so I'm not going to be able to simplify those on this side. But on the 1 and the -1, that's a 0 pair. Those will cancel each other out. 1 plus -1 is 0. So those are gone. I can take those away. I don't have another pair for this guy, so he's just going to hang out. Now on the other side, I don't have any partners for this x, but I do have a 0 pair right here. 1 and -1 is 0, so I can take those off of the board. Now I just made these sides a little bit simpler, okay? But now it's time for us to learn the rules of solving for x. The first step is to combine like terms and simplify. And I think we did combine like terms, right? And simplified on each side. That's what we did when we did our 0 pairing, okay? You can see that if we combined like terms over here, this side would be 3x plus 1, and this side would be 1x plus 5. So we have 3x plus 1 equals x plus 5. That was a simplification that we did by doing those 0 pairs, okay? So step 1 is done. Let's take a look at step 2. Step 2 is to move all x values to one side. Move all x's to one side. Now, the cool thing about solving for x is that it doesn't matter which side you pick. You could move them all to the left, you could move them all to the right, but you need to move all of them to one side, okay? They can't be on separate sides. So we need to somehow either move these 3 over here, or we need to move this one over there. Now, we've learned in the last video that with an expression mat, you can add or take away the same tile to both sides. In an equation, because both sides are equal, you can add or take away the same thing from both sides. As long as you do the same thing to both sides, that's okay. So you can do some pretty creative tricks to both sides in order to simplify this expression. But what we're going to do is we are going to add, we're going to add, I want to move, I'm just going to choose to move this x over to this side, okay? I think since there are already 3 of them over here, that it might be a good idea to move this x over there. There are other reasons, and as you practice this more, you'll know kind of which side might be easier to move to. But in this example, I think that I'm going to move this 1x over to the side with 3x. Now, how do I move it over? I can't just drag it over. That's not doing the same thing to both sides, right? So what I'm going to do is I'm going to take it away from both sides. I'm going to subtract x from both sides. okay? So that x is gone over here. But that also adds a negative x over here, because whatever I do to one side, I have to do to the other. If I subtract x from this side, it's gone. Then I also have to add a negative x to this side. When I add a negative x to this side, it cancels out with one of these. And you're left with 2x on that side. Are all of the x's on one side? Now they are. The next step in solving for x is to get x alone. Get x alone. Now with an expression, Matt, that's going to be a little bit trickier than when we're just working with the expressions. And I'll show you this exact same example when we're working with just the expressions, okay? But on this example, I need to get x alone. Are the x's alone on this side? No. They still have a positive 1 on this side. I need to get rid of that. Now, I can get rid of that positive 1 by subtracting it, -1. But whatever I do to one side, I have to do to the other. So I'm also going to subtract 1 from the other side. So this is gone. And then on this side, I'm going to add a -1. When I add a -1, you can see that it cancels out with a positive 1. And it makes this equation even simpler. Okay? Now, are the x's on one side? Yes. And are they alone? They are alone in that it's only x's on that side. What I would like to do is just get one x by itself so I can see what it equals. But for the example in this video, or at least at this point, I'm just going to leave these 2 x's here, okay? But there's nothing else on that side, so that's nice. Now, we are going to solve for x. For this video, because we're not going to take this 1x away, I want to just go ahead and share these tiles out. So I have 4 tiles over here and 2 x's over here. Let's share them equally. One x tile gets a 1, the other gets a 1. One gets a 1, and the other gets a 1. So x must equal 2 because each x gets 2. Each x gets 2. So x will equal 2. And that is how we solved for x using algebra tiles. Now we're going to take a look at how to do this exact same problem, but without any algebra tiles. We're still going to use our same steps, but we're not going to use algebra tiles for this. So let's take a look at, I'm going to refresh this so we can get the tiles back here. All right, so first we need to build these equations. So over here we have 1, 2, 3x plus 2 minus or plus -1 equals 1x plus 1, 2, 3, 4, 5, 6 plus -1. So that's my starting equation. I'm going to copy that onto another piece of paper here. 3x plus 2 minus 1 equals x plus 6 plus -1. I guess I'll make this plus -1, which is the same as just -1. Okay. All right. So now our first step, according to our rules of solving for x, is going to be to combine like terms and simplify. So let me go ahead and combine like terms and simplify. Combine like terms. Well, like terms over here, these I don't have any other x's for the 3x to combine with, but 2 and -1 are like terms because they're just constants, which means they're just numbers. So 3x, 2 plus -1 is going to be 1. So it's 3x plus 1 equals, I don't have any partners for this x either, so that x is just going to stay the same. But 6 plus -1 is going to be 5. And now I have combined like terms and simplified. That step is done. The next step is to move all of the x's to one side. Now I can move these x's I can move this x over to this side, or I could move the 3x over to this side. What's neat is I could do either of those ways and still get the correct answer. But I'm going to move the 1x to the other side, because if I moved the 3x to the other side, it would make, well, I'll show you what would happen. So let's go ahead and move this x over here. Now, in order to move it over, I'm going to subtract it from both sides, and we'll get 2x plus 1 equals just positive 5, where x minus x is 0. So 0 plus 5 is just positive 5, right? When I subtract this x, it's going to be 0 plus 5. Well, I don't need to write 0 plus 5. I can just write 5. Okay. Now, again, I could move the 3x to the other side. If I did move the 3x to the other side, it would look something like this. Minus 3x, minus 3x. And then I would have 1 equals negative 2x plus 5. Now, I can work with negative 2x plus 5, but it's going to be a little bit simpler. In my opinion, it saves a step dividing by a negative number at the end. Yeah, and so I like to keep my x's positive if possible. Okay, we know how to divide negative numbers, and it doesn't make it a whole lot trickier. But generally, I like to keep my x's positive. So I'm gonna redo what I just erased, and I'm gonna subtract x from both sides. And so x minus x is 0 plus 5. This is going to be 2x plus 1, but I don't need to write 0 plus 5. I can just have 5 there, okay? I also don't need to have that space there. I could move the 5 over like that, but I'm leaving it here so that you all see that x minus x is 0, okay? So we have simplified, or we've combined like terms and simplified. We've moved all of the x's to one side. Now we need to get x alone. So I'm going to get x alone, but I have two problems to getting x alone. One problem to getting x alone is this plus 1 right here. The other number that is with x is this 2. So I need to get rid of these two numbers so I can get just x on that side. How do I get rid of them? Well, the plus 1 I can get rid of by subtracting 1. So I'm going to subtract 1 from both sides. Whatever I do to one side, I do to the other. And now I'm going to have 2x equals 4. Okay, now I need to get rid of the 2. Well, how do I get rid of the 2? Now the 2 is right next to the x. And in math, it's called like the default operation, which is just a really fancy word for saying there is a multiplication symbol, a little multiplication dot in between the 2 and the x, okay? So when you have a number right in front of a variable, it means that number times the variable. And you just need to know that, because we don't usually write the dot in between the number, which is called the coefficient, and the variable, okay? So just so you know, there is a little multiplication sign, and it's kind of like invisible, between the 2 and the x, okay? So I'm going to rewrite that just as 2x. Now, how do I undo multiplication? How do I undo multiplication? Well, I do the inverse operation of multiplication, which is division. How do I undo addition? Subtraction. How do I undo multiplication? Division. So I'm going to divide this 2x by 2 to get rid of the 2. If I can get rid of the 2, then x is finally alone. I'm going to do the same thing to the other side, because whatever I do to one side, I have to do to the other. So now, and I'm going to have to continue my work up here, okay? If this happens to you on your paper, you can draw an arrow like I just did, or you can just write it next to it on the right side, okay? And I'll know what you're talking about. So now 2x divided by 2 is just x equals 4 divided by 2 is 2. X equals 2. Oh my goodness, we got the same answer that we did when we worked with algebra tiles. So we got x alone and we solved for x. X equals 2. There's one more thing I'm going to show you in this video, which is called the check step. Sometimes people make mistakes when they're solving for x, but there is a really cool way to check if you got the correct answer. And you can do this every single time to be extra safe and make sure that you really did solve for x, okay? And the way to do the check step is, I'm gonna make this, I'm just gonna write this over here, x equals 2. I'll write it small at the bottom right here. So x equals 2. So now we're gonna check our work. We're gonna check our work now. The way you check your work is you write the original equation and then you plug in x equals 2 where all of those x's are, okay? Don't skip a step. Don't enter it into this step right here. Don't enter x equals 2 into this step. Don't enter x equals 2 into this step. You might have made a mistake before those steps, but you probably won't have made a mistake on the very, very first step. That's why we plug it into the very top step, okay? So 3x plus 2 plus -1 equals x plus 6 plus -1. I am now going to plug in x equals 2 in for x, okay? So let's go ahead and do that. 3 times 2 plus 2 plus -1 equals 2 plus 6 plus -1. I just plugged in 2 where all of the x's were, okay? I wrote parentheses right here because this is 3 times x. Another way to show multiplication is by putting a number in parentheses next to another number, okay? Now, using PEMDAS, or order of operations, depending on what your teacher taught you, you know that we are going to multiply and divide from left to right before we do addition and subtraction. So the first thing I'm going to do in this step is to do all of the multiplication. In this case, I just have 3 times 2, which is 6. Now I'm going to add and subtract in order of left to right. And I can do this a little bit out of order due to something called the commutative property of addition and subtraction. But I'm addition, but I'm not going to do that in this video. I'm going to really use order of operations. So adding and subtracting from left to right. So 6 plus 2 is 8 plus -1 equals 2 plus 6 is 8 plus -1. Oh, you can see right away 8 plus -1 equals 8 plus -1, right? Okay, let's keep adding and subtracting from left to right though. So 8 plus -1 is going to be 7, and 8 plus -1 is going to be 7. Now, I know my answer for x was correct because both sides equal each other. Does 7 equal 7? Yes. So my answer is correct. Does x equal 7? No. The answers don't have to be the same as the variable, but the sides need to equal each other. So when x equals 2, my sides equal each other. So I know I got the right answer. If, let's just say, for example, this side was 6 and that side was 7, does 6 equal 7? No, it doesn't. So I must have made a mistake somewhere. But in this case, because 7 equals 7, my answer for x equals 2, must have been correct. So it's a really great idea to do the check step after each problem. I'm going to go ahead and write that here. Check step. Check your work. All right, and those are the most important things you need to know in order to solve for x and solve for one variable equations.